Alright, today we're going to go over Kareen, but just to show you that what we went over yesterday was not all completely worthless, I'm going to tell you about the Ackermann function, which is a very famous function in mathematics, and if you look it up on the internet, I bet in Wikipedia you'll get a wonderful article about it and what all the wonderful uses of Ackermann of the Ackermann function mathematicians have done. So let's define Ackermann. We can define it using this super order function which we've made very easily, in fact. Define Ackermann lambda n super order n n n, and that's the Ackermann function. So now you know how to define it in Scheme, and I'm afraid it's not going to be very useful to you the way we've defined it though, because like Ackermann of 1 is fine because that's super order 1 to the 1 1. Even Ackermann 3, Ackermann 3, that's yes, Ackermann 3 is even fine. Ackermann 4 though, that is it's approximately 10 raised to the 10 raised to the 153rd power. So that's at least 153 digits long of an answer, which is a bit it's a bit much for Scheme to handle. Alright, so let's stop this and start going over Kareen. Alright, so let's see here. Let's define a procedure. Let me clear out this. It's garbage that we don't need to see anymore. Alright, let's define a function called round n places. So let's say we've got we've got 17.0 divided by 13. Oh bother, I hate it when it gives me that warning. Right, 17.0 divided by 13. It's 1.30769 ... Alright, so let's say we want to round it. Now Scheme provides a function called round that let's see, yes, it rounds its arguments to 0 decimal places. So like round of 1.3 ... would equal 1.0. Now how's that going to do us much good? We want to round it to like 4 decimal places. Alright, let's say we want to have 3.07, well that would be 077. Alright, so how are we going to do that? Well, we have to first multiply this by like 1000 and then round it and then divide it by 1000 again. So let's try that. So divide round of times this number here, which I'll just paste right there. Let's see, we have to do 10,000 since we have to round that last point as well. Alright, then divide it by 10,000, and there, oh that's beautiful. Alright, so let's say we've let's define this then. Define round n places. So we want this wonderful thing, a rounding thing happening, but we want to specify how many places, and the places is determined by this number determines how many places you'll have. So if it's 4, then we want to multiply I think that's like 10 raised to the 5th, I think. Oh no, I think that's 10, let's see, 10 raised to the 4th might be 10,000 right there. So exponent 10 raised to the 4th. That's 10,000. Alright, so we can just well, define round n places, lambda x and n. Alright, so n is the number of places that we want to round it. So we're going to use a let statement so that we can get this nice answer there. Alright, let factor equal the exponent of 10 raised to the 9 to the n. Alright, then anywhere within here we can use that, so let's use it in here. Divide the rounded number, so it's just like this here, except instead of 1000 we're doing n, and instead of 1.3 dot 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 we're doing x up here, because that's the number we're going to get. Right, times x, and then factor, and we want to divide that by factor. Right, let's run that. Round n places, 1 point dot dot dot, and n. Oh, let's do 4. 3, yes, 3. Alright, we can do it again, but this time let's do like 7. Alright, so it's working just fine. Now let's see, what if we want to like round 2? Define round 2 lambda x. Oops, we can just use this here. Round in places, round in places, x and 2. Alright, then whenever we want to round something like let's see, round round 2, 1.9999, 2.0, right, round 2, 1.333. Alright, so that works really nicely. But let's say we want to let's make a function that will return the round in places of any number that we give it, so that it's easier to define these things. So let's call it round maker. Define round maker lambda n, and we'll return a function. Well, we can just basically return this. We could just have it return round in places of oh no, we don't know x, do we? Oh, so we have to return a function here, lambda x, that returns the round in places of x and n. Alright. Okay, so let's run that. This ought to work really nicely. Let's do round maker of 2, 1.333. We should just get 1.33. Oh yes, that's good. Okay, so let's see here. Alright, so let's redefine this round maker. My notes have it defined actually calling this inside here. Not just calling round in places. Alright, so let's just copy and paste this in there to redefine that. Alright, so alright, so we redefined it. Right, now we're going to continue this on into the next version of the video.